Hey everybody, Hank here. Now I'm always on the lookout for new ways that we can get started with network automation in a super easy to use fashion. One of the things I've been focused a lot on is this kind of crawl, walk, run progression for network automation, because it can be hard to dive into some of the topics that require some background knowledge in APIs or programmability. And I don't know if I've ever been quite as excited as I am once I was introduced to the Genie CLI that was brought out as part of the pyATS and Genie version 19 release. Now this is a tool, Genie and pyATS is a tool I've been excited about since I first learned about it a couple of years ago. But what's new now? Now the pyATS and Genie tool is something that I've talked a lot about. I've done videos, we've blogged about it, I use it in a lot of my cases. But what's new with this version 19 release with the Genie CLI is that it pulls away all of the requirements to understand how testing in Python works or how to leverage a tool like the robot framework. You can dive right into the power of pyATS and Genie for checking the current state and health of your network, and then comparing and contrasting that as things change without having any kind of background or experience with any types of these programming characteristics. You know, the easiest way to see this is to see it in action. So let's do that. Now the network that we're going to be using, I've got shown up here on the screen. Now it's a fairly basic network. We've got this kind of data center representation with a couple of servers, access switches, distribution switches, a core layer. We've got a WAN router out here, and then we've got a branch location behind a firewall and a switch and a server out there. So it gives us enough resources that we can actually kind of work with it as it goes through. Throughout the entire demonstration, I'll be using this topology, but we'll be injecting problems into the network that we're going to be using Genie, the Genie CLI to find, deduce, and figure out where the issue is as fast as possible. But all along the way, it'll be this same topology, and we'll bring it up if we need to as we go through. Now, in order to get started with pyATS and Genie, this is a Python application, and so you'll need Python 3 installed, and I'm highly recommending everybody be on 3.6 or even 3.7 if you've pushed there. And so if we look, I've got Python-V, I've got Python 3.6 installed, and I am running this inside of a virtual environment, good best practice for just about anything as it goes in. Now to install them, you do this like any other Python package, so pip install pyATS and Genie. Now the screen just flew past because I'd already done this installation. You can see all these requirement already satisfied bits, but that just shows it's that easy to get installed. Remember, pyATS and Genie completely free, available up on PyPy, like all the Python pieces that are there. Now the first bit we want to do is the way that Genie functions is Genie. Now the first thing we want to do as we go through here is learn a baseline of what our network is supposed to look like. And with the Genie CLI, it's really quite simple. So we're going to do Genie learn, and then we're going to say learn everything that we can possibly about our different network that's out there. And then we have to give it what's called a testbed file. So testbed file, and then the path to it. And we're going to look at this file in a second, but we're just going to run this real quick. So mock normal, testbed.yaml. And then where do we want to save the results of this profile? Because what Genie is going to do is build a profile of our entire network. And let's say we're going to save this off there, and we're going to save it in tests. We're going to call this the normal. So this is our baseline of what we're after. So I'll go ahead and run this. We can see all of the different things that Genie is learning. It's learning access control lists, ARP status, BGP, HSRP, interface information, kind of a whole shebang of the different network services that we're probably running in the network. And it's doing this across our entire environment. So we can see switch 2, 5, router 1, all across as it goes through. Now Genie's kicked off, and we've got a progress bar here showing. We can see there's 28 little steps that it has to run through, and so it's going to process in. Now to learn everything about the network can take a couple of minutes, and so we're going to let this run and we'll jump back in when it's done. Okay, so the Genie learn all has completed. Let's take a look at what we've got in our output here. So I'm going to scroll back up to the very top because we get lots of details. Let me find where it was. Here we go. All right, so here's where that progress bar was going. And we can see that it took 2 minutes and 17 seconds to learn all of those details across our entire environment. And so we get a Genie summary across each one of these devices. And so we can see everything that kind of went through. So we connected to switch 2, and then we've got a log of what that connection looked like as we connected in. And then for every feature, Genie gives us the fact that it's kind of learned that feature, and we get 2 different pieces of data that are saved as part of this profile. we get what's called an ops structure. This is a structured data, specifically it's in JSON format, of everything that there is to know about the access control list on this device. And then if you wanted to see the actual output that Genie had gathered and then parsed down to create those JSON structures, we also save that here. So this console output is the exact console output. So we can take a look at one of those here. So if I open up here, we'll say tests and normal. And we'll find the access control lists for switch 2, the one that we were actually looking at there. So switch 2. So we'll start with the console output. And so here we can see that it ran the command show access lists, and this was what the device sent back. It's exactly the same output that if you were to run that yourself. And so we can see the extended access list, right? We've seen this text data before. Now we capture that, Genie has that in case you want to see it, but the most interesting bit is the actual parsed piece of data here. Now I'm going to tell Adam that this is JSON data, and so it color formats it for us. But this is actually a JSON object, right? So I've got the curly braces, I've got keys, I've got values, and so I can see the info. I got access control lists, I've got the access control list name, and then the access control entries, right? So 100, deny, log none. So all of the details about that access control list was formatted and put into this JSON object automatically just by telling Genie to go ahead and learn that for me. Now, if we look at the list, I've got that same information for the ARP list, the BGP, .1x if you have it configured, HSRP, and so on, all the way across. So remember, what we've done is we've profiled our network in its current functioning state. And what this gives me is this gives me a baseline, a known good baseline that I can use as a comparison point. So this is going to bring us to our first kind of interesting demo as we go through. So if I bring back up our network diagram, where did it go? Here it is. Shrink that down, make it a little bigger. And so in our first case here, what we've got is we've got reports from the systems team that server 1 down here and server 3 can no longer communicate with each other, right? We get these types of service tickets all the time. Now looking at our network, seeing how it goes through, odds are good you're thinking some potential problems that could have caused that type of connectivity issue. Now, lucky for us, with Genie, with the Genie CLI and its ability to profile the network, we can jump right in and start going through. So I'm going to run this Genie learn command. And so before I execute it here, we're going to run again Genie learn. Now in this case, rather than learning everything, I'm going to key in a few areas, right? I'm a network engineer. I've got some ideas and things that I want to learn some current state about my network. So I want to learn about the interfaces, the OSPF routing protocol. That's what we're running on our network. The overall routing table, and then VLANs, right? VLANs can always cause problems with connectivity. Now our testbed file this time, now in this case, rather than using the normal testbed, I'm targeting a different testbed that actually has this problem in place. So we've injected an actual network problem into the topology. And so I'm going to actually I'm going to run Genie learn against that problem-based network, and that's based on this testbed file that's there. And then I'm going to save the output here into this demo 1.1 directory. And that will save all of those operational details, the JSON files, everything that's there. So let's go ahead and run this one. Now this time, right, instead of learning every feature, we're only learning the ones I asked about, so we can hone Genie into the specific features we're after, and it's going to go across our entire devices. Now it's less features, so it won't take quite as long as it did the first time. We'll check back in here as it's done. All right, we are all done. Let me scroll back up to where this test ran. Okay, so what we can see is our output, how it starts. There we go. All right, so this run here, there's our progress bar. We can see it took 28 seconds, so less than half a minute to run all of those features across the board. And so we get our summary. We can see we connected each of the device, we learned about the interfaces, we learned about OSPF, we learned about routing, we learned about the VLANs. And we stored all of that profile information inside of the demo 1.1 directory in our test subfolder. And so if I come back down here, if I look in that directory, so ls-l, we'll say tests, we see that I've got my normal one. That was the baseline we ran. So that's our entire known good, known functioning profile of our network. And now I have this 1.1 folder that has a series of features in the current state when our network is having a problem that's out there. Now, Genie gives me the ability to run lots of things other than just learn. So if I do Genie --help, we can see that Genie also has this diff command, right? The diff allows me to actually compare two different snapshots that we have. So this is what we're going to take advantage of now. We're going to compare the normal, the known good normal state, to what we currently have when we have an outage out there, looking for differences, looking for problems in the network. So to do that, it's simply Genie diff, and then you give it the two things you want to compare. So tests normal. I always like to give the baseline first. So here we'll see the changes from normal rather than seeing kind of the other order. So I like to do normal first, and then tests demo 1.1. So we'll pair those, and then I'm going to save the output of that to the diffs directory and say demo 1.1. So this is going to compare both of those files and save all those differences in that folder for me. So we'll go ahead and run this. All right, this takes just a blink of an eye. I didn't even have to speed up or cut the video at all for this one. So I'm going to scroll back up to the top, and we can kind of see what Genie's output gives us right away. We got lots of files that were compared, so I got to scroll way up here. There we go. So here's our command. We can see it took less than a second for it even to run as it went through. Now you'll see we've got lots of files. So many of these files are going to report that they're only in tests normal. And that's because when we did our profile of the entire network for the baseline, we profiled every feature. But when we learned it when we ran our Genie learn the second time, when we had the issue, we kind of honed in on just a handful of features. And so, for example, we did not relearn the ARP state, so we don't have an ARP in the test demo 1. So this one says only in test normal. That's expected. I didn't relearn ARP information. Same thing with Lisp, right? Now we also see this one here, file, OSPF, IOSXE, switch 1 ops. And so this is the operational state of the OSPF process on switch 1. These files are identical. And so this tells me that there's been no change in the OSPF process on switch 1. Now in our topology here, switch 1's not running OSPF, so that's kind of expected. And so what I'm looking for is I'm looking for cases where there's actually a difference reported. So I'm going to scroll through here until I can find one. Here we go. So I've got file OSPF, IOSXE router 1 operation. So the operation state of OSPF on my router, and I actually am running OSPF there. I can see that there's a diff can be found. So there was differences found between the normal state of OSPF and the state that we currently have. And so I can find that file in diffs demo 1 and then the diff for that one that's there. So I've got that. If I look down here below, I also see that I've got differences in the routing state on router 2, right? And the diff for that can be found there. And so if I scroll through, there's a handful of them, but each one of the files that could be checked are all reported. Now, this is a long list. I actually find sometimes it's easier just to look in the diffs directory and see what files were created. So if I do a, ls-l diffs, no, that's not what I want. Diffs demo 1, we can see that we've got these diffs were created. We've got OSPF IOSXE router 1, OSPF on router 2, OSPF on router 3. So it looks like something changed in OSPF. Also, the routing, there's some routing process differences across the routers as well. Again, not terribly shocking. Let's actually look at the routing one first. So I'm going to go ahead and open up the differences on router 2. We'll just start there. We'll pick that one. And so I'll come over here, we'll find it, diffs, demo 1, and we'll say on router 2. All right, so let's take a look. So we've got, when we look at our diff here, we can see that we've got info, VRF, default, address family, IPv4, routes. So what this is this is a comparison of what the status was of normal to the current state. Now in a diff output, minuses indicate lines that are not present in the in one file, but are present in the other. And so in this case, our current state is missing this block of lines. Now this is a block of lines for a route to 10.0.128.0/29. Now that happens to actually be the route where server 3 sits on. Now if we remember, what we're looking at here is we've got a reported problem. Let me grab the network diagram here. We've got our reported problem that server 1 can't talk to server 3. And we've just found out that we actually are missing a route on router 2 to get to the subnet that server 3 sits on. That clearly indicates that there's probably something going on there that we want to dive deeper into. If I scroll down a little bit farther, we're going to see we've got some updated information on hop list. So it looks like something changed in the routing process, right? So we can see that information that's there. You know, what we can also take a look at is let's look at some of the information on these other ones. So we'll take a look. So that's router 2. What about the rest of the routers? So we look at router 3. Well, this looks really similar. We're missing the route on router 3 as well. So this tells me that whatever change happened, it wasn't isolated just to router 2. And if I look at router 1, all right, well, router 1 looks a little different, right? So we don't have these going on. We don't have this route here that's been missing. But router 1 does have some updates that were gone through there. So something different going on. Something routing looks like it's changed. Now we're running OSPF, and we also know that we've got some OSPF diffs that came up out of our piece that's there. So let's take a look at the OSPF diff on one of these. We'll pick router 3. All right. So here's the changes in our OSPF knowledge that's out there. So VRF, default, address family, IPv4, instance 1, right? So we're at instance 1 of OSPF, area 0, the database. And so we've learned the entire OSPF database. That's part of what Genie pulls in. And what we're finding out here is that there's an LSA type, a type 5 LSA that's missing now. Now there used to be a type 5 LSA, normal had it, but Genie, the diff here, tells us that it's missing very quickly as it goes through. Now the LSA is specifically for that 10.0.128.0 network where our server 3 is listing on. And it's an external LSA as it goes in. So we've learned very quickly, okay, so we know that we're missing a route to server 3. Well, let's take a look. Like, there's lots of reasons that route could have disappeared, but let's go ahead and drive right in and kind of see if we can figure it out. Now, if we look at our topology, right? If I go find my topology again, here it is. So the route for this, might make this bigger. So the route here, right, to get into the WAN needs to exist on router 1. And in fact, if I go and I look at our actual status of what that LSA was, it was coming from the advertising router 192.168.255.1. And that's the loop back for router 1. I know that, right? So .1, so we know it's been lost from here. Let's take a look at the configuration changes that are there. Now I could log into router 1 and we could look at it. But that would be really hard to kind of parse through the entire config looking for something that seems odd. Rather, we can use Genie to look at the config and then give us a quick diff that's out there. So we're going to run another Genie learn command here. Let me grab it out of my cheat sheet a little bit. All right, so we're going to learn, this time we're going to learn the configuration of the device. Our same testbed file, here's our testbed file with our problem that's in the network. And we're going to save the output here. We're going to save it to the test directory and then demo, kind of wrapping here, but demo 1.2 folder. And since we only are interested right now in router 1, we're just going to focus just on the router 1. So let's gather that info. We can see it's learning the config on router 1. Our summary comes through and says we've connected to router 1, we learnt the configuration, and it's all been kind of saved and parsed for us. I can go look at it, but why do that when the Genie diff can do it all for me? So Genie diff tests normal, and then tests demo 1.2 this time. We're going to save the output to diffs demo 1.2. All right. So remember, it's going to try to diff every file that we had from our normal baseline, which was far more than just the configuration. But if I look for what was actually found, so ls-l, and we'll say diffs demo 1.2, we can see that there was indeed a difference found in the configuration that's there. So let's open that diff file up. Here we go. So I've got my diff file. We're comparing the normal one, right? Our normal status when we know the network is good to the demo 1.2 when we have our problem in the network. And lo and behold, look at this. There's a static route statement from the configuration that's missing. So this tells me right away, now I know why that LSA is missing. The static route for that is missing from router 1, so it couldn't have been redistributed into OSPF and then shared. And this gives me the ability to drill right in. Now, it took us several minutes to kind of go through this, but most of it was really just me talking. If we look at the process of using the Genie CLI, within a matter of about 5 minutes, we would have profiled we already had our profile for our known good network. We would have profiled it when there was a problem, compared the differences, and come in here and seen that we're missing a route that's out there, and we could go ahead and replace that as it's in place. Right? Super powerful. Under the hood, we're using Python and a whole bunch of features. But as a network automation engineer just getting started, I didn't have to know any of those areas, right? It's a simple Genie CLI command that we're using, right? All right, so let's take I got lots of other demos we can run into, but what I want to talk a little bit now is under the hood, what's going on in this place. So the first thing we want to talk about are the testbed files. Now, Genie needs to understand what your network is. It needs to know how to connect to your network that's out there. And so to do that, we use a testbed file. If you've experimented with other tools like Ansible and you've used an inventory file, you can think of the testbed file like the inventory file. Okay, so let's open up an example testbed file. Now, the testbed file is a YAML formatted file. If you've never run into YAML before, it's a data format similar to XML or JSON, but the way that YAML works is it's a series of keys and values. So we've got the key here, name, colon, and then the value is Genie CLI, default, and so on. And then we've got a username, key, and a value of Cisco. YAML's white space sensitive, so it's the indents show where things belong inside the structure. Now the testbed file goes out and it starts out here. It says we've got a name of our testbed, so you can have different ones that are out there, and this is kind of a random name. And then we've got our credential information. So the TACX username for my network is Cisco. The passwords for my network, right? The TACX password is Cisco. The enable password is also Cisco, and the line password is, once again, Cisco. The network we're using for our tests here is a viral-based simulation, and the default credentials in there are Cisco. Now, a quick note here. So I've got them hard-coded in this example testbed file, but you can actually pass in and read usernames and passwords and all these things from environment variables, or have pyATS and Genie pull them out of other locations. I often use environment variables for it. But if it's a lab and a test, you can certainly bake them directly into the YAML file if you're not worried about sharing them. After we get through kind of the default information here at the top with credentials, we get into a devices list. And so I've got router 1 for our network. The alias is router 1. Its operating system type is iOS XE. Its type is iOS V. And then connections. Connections instructs Genie how to actually connect to the device. Now, Unicon is a built-in part of pyATS. It's the universal connector, so to speak, and knows how to connect to devices across a variety of means. We can see that we're connecting using Telnet, and then here's the IP address for this device, and then some pieces that are kind of default that goes in. Now, as we scroll through, right, each one of these devices basically is a copy and paste with just the differences of the device name and the IP addresses that are set as it goes through. So this is how we set up our testbed file as it goes in. Now, I have a testbed file that kind of represents our normal state of the network, and then another testbed file that connects to a network that's got injected problems, and those are the other testbeds, how we were bouncing back and forth in the demo as it goes through. Now, the last demo that I want to run through on the video today is to kind of dive a little bit deeper into how Genie actually processes and learns all of these pieces. Now, we saw, right, Genie ran and captured console output and then converted that into a JSON body format. That process is called parsing of the data. And so if I go and we look at one of our examples from one of our tests. So I'll go to demo 1.2 here, and we'll look at the console output from our config. Actually, that's a bad example. We won't look at that one. We're going to look at test demo 1.1, and we're going to look at the console output from, we'll say, the OSPF information. So OSPF router to console. All right. So here, this is what Genie actually received back from our device. Show IP OSPF is what it sent, and then this is the block of text that came through. Now, Genie received this back and then converted that into the JSON format where it's all been processed as it goes in. Now, this is where the power of Genie under the hood comes from, is its ability to parse this data automatically. Genie has a built-in series of auto parsers for different commands across the environment. So if we go and we check the documentation, Here we go. So I'm over here. I switched over to the online documentation that's hosted up on DevNet for the parsers list available for Genie. We can see the all list. And so iOS XR has a command admin show diag chassis, show ARP detail. So these are the commands for these types of devices that Genie knows how to parse and turn into those JSON formats. We'll switch over to iOS XE. Those are the types of devices we're looking at. And so in here we can see that Genie has parsers to know how to deal with all of these. Show BGP all, show boot, show environment. So each one of these show commands, under the hood, Genie comes included with the automatic ability to parse that clear text string data into the JSON formats. If you've done network automation before with tools like NetMiko, maybe you've leveraged things like regular expressions or find functions, or even text FSM. Those are great, you can get a long way, but what's nice about when you use Genie is all of that is built right in for tons of different features, right? And the way that these commands were kind of deduced is based on the different models of actual network features that are there. Remember, we ran that Genie learn command and we learned a series of features. Now here's the list of all of the features that Genie understands. We've got, where were they? We looked at OSPF, we've got LLDP, we've got interface information, VLAN, segment routing. Now behind each one of these models is a series of show commands that you need to run to learn all of the current state about these features. And that's how the Genie parsers and the Genie models kind of fit in, is there's a model for segment routing. To learn about segment routing, there's a series of different commands that need to be run. Now you can actually take advantage of these parsers on their own as they go through and process that data. So let's see that in a demo. So I'm back over here, and so we're going to run a demo of some of these parsers that are out there. Now we'll start out with, let's look at the help information. So Genie parse -- help. And so we can see to use the Genie parse command is we give it the command we want to parse and then options. And we get some nice examples. So Genie parse show interfaces. You of course have to give it a testbed file so Genie knows which network to connect to. And then you can specify specific devices you're interested in. In this example, there's a device called UUT, but our devices are right, RTR1, RTR2. And then you have the ability to output that to a different, output the saved data and capture it as it goes through. So let's run one of these examples, right? So we'll do Genie parse, and we'll do the same one. We'll do show interfaces. We're going to give it our testbed file, and our testbed is testbeds, and we'll do normal. So our normal state. We'll check the interface state when our network is functioning appropriately. And we'll hone in on one device. So we'll say devices, and we'll check RTR. We'll say 2. So this goes ahead and runs. All right, so it runs pretty quick because it was just one device when one command we're parsing. I'm going to scroll up to the top of where this output starts. Way up here at the top somewhere. There we go. So here's where our Genie parse command went. We can see again it took less than a second for it to process and go through. And then we get our output. So Genie ran show interfaces on router 2, and then it processed that into a JSON object. So we get gigabit Ethernet 00 is one of the interfaces. It's ARP timeout, it's ARP type, it's bandwidth, all the counters from the device so we can see what's going on. We've got, look at that, some in errors that are out there, something to deduce. We got in octets, we've got packets, runs, all of this information that we could dive into under the counters. Scroll down a little bit farther, we can see the delay, we can see the description. Is it currently enabled? We can see the IPv4 address information that's out there, keep alives, see the queue information. All sorts of details about gigabit Ethernet 00 is all stored and easy to use and process if we wanted to read this into some other device and take advantage of it. Now moving on, we get gigabit Ethernet 00, right? More than one device on my router, here's the other one. All the same information. Now there's some magic that's here even outside of the fact that Genie was automatically able to run that command and then turn the data into something really useful from a programmatic perspective. The extra magic is that if I ran the show interfaces command against an iOS device or an NXOS device and an iOS XR device, the data format for that gets stored is exactly the same. The counters, right? We've got a counters key and then we've got in broadcast packets. Now, on the actual devices that may be referred to differently between XE, XR, and NXOS. But when Genie normalizes all that information, this data format, all these keys are exactly the same. And this will be for all of those parsed commands. This means that it's very easy to compare, for example, the output from a show VLANs catalyst switch to a Nexus switch, or to look at the output from show OSPF and compare the OSPF routing status between all three different routing platforms. Doesn't matter, because Genie turns it into the exact same data format, making it really easy to parse. Now, I could go on and on probably for hours going through several different examples on how Genie CLI can help save you time as you're learning status, comparing, figuring out what's changed in your network before and after some sort of an outage or configuration change. But why don't you do it yourself? One of the things that I've done is that I actually took all of these examples, the couple that I ran here, as well as several others, and I have them shared up on GitHub, and you can run these examples right away all by yourself. All you need is a computer with Python installed and it'll go forward. You'll find that up on GitHub, so let me go ahead and browse to it. So github.com, hpreston, and it's in my NetDevOps demos repository where I've got a series of different demo information. And it's this new demo here, Genie CLI. And so we've got this Genie demo or Genie CLI demonstration. This will walk you through getting yourself started and going through these same examples. So it'll help you prepare for it, right? So you'll clone the repository down, you'll change into the directory, get your Python environment installed and set up, do that initial profile of the normal network as it goes through. And then what I've got inside here is a series of demos and exercises that'll walk you through taking advantage of the different Genie CLI operations, learning, using diffs to nail down different problems. I have several different simulated network challenges that are there. So demo 1, we did this one online or in the video, users report problems connecting from server 1 to server 3. In demo 2, we've got occasional network communication issues on server 1 and server 2, right? So that's like a help desk ticket that's been opened, and the demo will walk you through using the Genie tools to figure out what the problem is. Now, these last 3 demos, server 2 can't communicate with anything, non-optimal traffic patterns, and demo 7, performance problem somewhere. Now, these are ones where I haven't given you the answer keys, but it'll give you the opportunity to leverage the Genie CLI to see if you can figure out what problem I actually injected in the network as it goes in. Everything you need to learn about and experiment with Genie CLI are included in this repository, and you can dive right in. Well, I hope you found this video introduction to the Genie CLI as interesting as I find the feature. This really is one of the most exciting kind of entry-level network automation tools that I think anybody can take advantage of right from the get-go. And then as you start to progress yourself from crawling to walking and running, what's nice is the pyATS and Genie package will grow with you, allowing you to take advantage of more sophisticated network tests and network verifications as you're ready to absorb them. But as you've seen, you don't need that skill set to get started today. Right away, you could take advantage of Genie Learn All, point it at your network, and you'll get a profile of every network feature that you've got from layer 2 and layer 3, access control list, quality of service, all sorts of those pieces. You'll get a snapshot immediately. And the next time you have a network problem, you can just do another Learn All, run the diff, and see all of the differences between when your network was fine and when you now have your network problem. That can happen immediately with very little experience, right? Because all you have to do is run those Genie Learn and Genie Diff commands as it goes in. If you found this interesting, please reach out and let me know. I'm up on Twitter at hfpreston, or just leave comments here on the video. And stay tuned for more information, all related to network automation and NetDevOps. Talk to you soon.